Hey there, everybody. This video is going to be the first under expressions, equations, and inequalities, and it's called Combining Like Terms with Negative Coefficients. So, the directions say combine like terms to make a simpler expression. It's important to know that we are not solving anything. We're taking an expression and making it simpler. And this is the expression we have, and we want to write it in a more simpler way. Now, I'm going to prove to you when we're done with this that it is actually the same exact expression, but let me show you first what we have going on. So negative 12 minus 6p minus negative 2 is the same as having negative 12 minus 6p minus negative 2 becomes plus 2. All right, well, looks like a couple of these are terms that we can combine. Now, I always tell students, get in the habit of putting the variable expression or the variable term first. So negative 6p is just negative 6 times p. And negative 12 can combine with positive 2 to make negative 10. And this is the simplified way of saying this. Right? Now, I always use this example in class, and you know, if somebody asked you how old you were, you could say, I'm going to erase this when I'm done, but just show you. I am 12 years old. Okay, most seventh graders start out the year about 12 years old. And would it be wrong for you to say, I am 20 plus negative 8 years old? It wouldn't be wrong. It would be weird, but it wouldn't be wrong. All right. I always consider 20 plus 8 years old is the unsimplified way of saying something, and 12 years old is the simpler way of saying something. So these expressions are equal to each other. They're equal to each other, but one's a complicated way of saying it, one's a simpler way of saying it. All right, so, and I'll prove to you. So we're going to pick any number in the world. I don't know, 5. If I plug in 5 into this expression, and I plug in 5 into this expression, the two numbers will be equal to each other. You know what? Uh, if I plug in 7 into both expressions, the two numbers will be equal to each other. I'm going to plug in 5 just to prove to you, but it doesn't really matter what number I put in. So I'm going to plug in 5 for p. So let's say when p equals 5. I'm not saying p does equal 5. I'm just proving to you that these two expressions are equal to each other. So in the first case, negative 12 minus 6 times 5 minus negative 2. Well, this is the same as negative 12 minus 6 times 5 plus 2. Order of operations says I need to do 6 times 5 first, so this would be negative 12 minus 6 times 5 is minus 30, or negative 30, depending on how you look at it, plus 2. Negative 12 minus 30 is negative 42, plus 2 is negative 40. Now I'm going to take, in purple, this expression, plug in 5, and see what happens. Well, negative 6p times 5, negative 6 times p, minus 10 is negative 30 minus 10, which is negative 40. Okay. Now I promise you, no matter what number I picked, the two values, it wouldn't have been negative 40 necessarily. Actually, it only would come up that way for 5. But no matter what number I put in for p in the original expression and in the new expression, the two would be equal to each other. So I hope that makes a little bit more sense. Let's simplify another one. So this is combine like terms to make a simpler expression. So 5k plus negative 2k minus negative 1 would be 5k plus negative 2k minus negative 1 becomes plus 1. Okay, put my commas in. My terms are 5k and negative 2k and positive 1. I would combine 5k and negative 2k to make 3k, leaving me with plus 1. So I'd write plus 1 here. So this is the simplified version of this expression. All right, we have the original expression, and then we have a simpler way of saying it. Try one more. Negative 4r minus 2r plus 5 would be negative 4r and negative 2r and positive 5. So negative 4r and negative 2r together make negative 6r. That's an ugly r. Negative 6r. All right, leaving me with positive 5, which is plus 5. Now, just thought of something. Students sometimes will get something like this. They'll get 5 minus 6r, and they'll say to me, is that correct too? And the answer is yes. All right. If I put a comma in here, I put a comma in here. This expression has negative 6r. This expression has negative 6r. This expression has positive 5. This expression has positive 5. So whether I add them in this order, negative 6r plus 5, or 5 and negative 6r, they are equal to each other. But get in the habit of putting the variable first. Okay, the variable before the number at the end, which is called a constant. It'll become, it's just standard practice in math to have the variable first. I really have the handwriting of a 5-year-old. All right, let's go to the next one. Y minus negative 3y. Well, this is y minus negative becomes plus 3y. So y is just, well, 1y. Plus 3 more y's is 4y. So the complicated way of saying y minus negative 3 times y is just saying, oh, I have 4 times y. I hope you enjoyed the video.